Hello guys, welcome to our next video in the playlist Google Earth Engine for the land core applications. So in today's video, we are going to learn how to do a supervised classification. So in the previous video, we have covered unsupervised classification without any training inputs. We have used the k-means of algorithm, the and cluster algorithm in order to classify a land satellite image. So in today's video, we will do a supervised classification with the proper training inputs, and we have the control over what the pixels can be classified as. So let's start by creating a region of interest. So I'm moving to any region in India. I'm zooming into a part in the South India. Okay, so let's create a region of interest by drawing a rectangle. So you can use these geometry tools and just draw it. Okay, so sorry, I have created two rectangles. Let's delete this and add it now. Okay, so you can rename it as ROI, region of interest. You can uncheck this geometry, and now you search for our usual data set, that is Sentinel 2A. Okay, import it. Let's name it as S2. So we need to multiply it by its scale factor, that is 0.001, in order to go for any kind of analysis later. So here you see the scale is 0.001. So let's create a variable called pre-image, and let's filter this sentinel collection to our boundary by using the function filter bounds to ROI, and also filter it to date, latest 2024 January 1 to, let's say, 2024 okay, November 30. So we are taking the median of this at last, and we should also filter the cloud cover by using the function filter metadata. So open our Sentinel-2 dataset, go to the image properties, and select this cloud pixel percentage and paste it in here, and use the arguments less than. So should always use underscore, do not use the space at any situation. So we have filtered our Sentinel image collection for the cloud cover, date, and bounds. So let's see how many images are available in these filters. So I am printing the pre-image. Let's give it a run. Our image collection is loading. Okay, we have 14 elements under these filters. I'm taking the median of it after multiplying the scale. So let's create one more variable, say image is equal to, for the pre-image I'm applying the map function, so that for every image it should follow the same function which I'm creating. So I've created a function which takes the input image, and I'm giving the arguments. It should return an image multiplied with its scale factor. It should be multiplied by its scale factor. So use the function dot multiply with 0.0001. Okay, so now take the median of those images and keep it the origin of interest. Just give it a run. So I will add our true color map to the layer with the use of the function map.add layer. We are adding the image. Select the bands. It should pass in bracket. So I'm giving the true color image for red, green, and blue. I'm using red, green, and blue only, and the minimum value will be say 0, and the maximum value will be say 0.3. After multiplied by its scale factor, the reflectance values will be this much only for the Sentinel-2 data, and let's name it as a true color composite. So running now. Yeah, So you can switch to satellite mode, uncheck the labels, simply zoom in. So in order to set the zoom level, I'm using the inspector tab. So here you can see our zoom level is 13. So let's use the function map dot center object to region of interest with the zoom level of 13. So yes. So also if you want to switch to satellite mode every time, if you don't want to switch, you can use the function map dot set options function to satellite mode. So this will change your base map to satellite instead of terrain mode. Yeah. So now I'm starting with the creating an input. So let's zoom in to check what are all the inputs do we have. So here you can see the agriculture lands. So you can slightly reduce the true color image in order to see the base map. What does it contain? So clearly I can see some barren land, some agricultural lands, and some build-up lands. So some water bodies also there. Okay. So let's start with creating training inputs. So my first class will be build up, which means what are all the classes comes under the buildings, roads, everything will be included in the build up. I'm giving it as class 1, and I would also have another training input as agriculture land. I will simply name it as agri. So you can have the full name if you want, and it should be a feature collection. And the class will be 2 for the agriculture lands. So you can also change the colors here if you want. And one more layer will be, say, water, and it should be again a feature collection. So remember to name the property as one uh, class in each of the training inputs. So we have the build up, we have the agriculture land, we have the water. Okay, one more we'll have is the barren land. Okay, so it should be a feature collection, and let's import it as a class 4. Yeah. So let's start giving training input. So now you can simply adjust this transparency in order to have a better idea. Oh, sorry, I should have unchecked this. So let's delete this. Yeah. So here you can see it is a build up. So yeah, these are all the build up. So you can also use the point geometry for choosing the training inputs. So since I had created an region of interest with rectangle, so it has taken rectangle only, no issue. So just it will calculate the reflectance values from it. So here you can see these are also build up, this road and all. Okay. And I will also give some of the inputs for agricultural land like this. Here you see these are the agricultural lands. So if we can just come this side, yeah, here you will see more clearly the agricultural lands. Simply draw it. Yeah. And should also give the training inputs for the barren land. So here you see it's a barren land, either degraded or not. So yeah, and I should also give one more training input for the water body. So here you see it's a water body now. Switch to water bodies. Yeah, it's all whatever is. That's it. So if you have more amount of training inputs, your classification would be better. So I am just giving this much in order to make the video shorter. So you can uncheck all these geometries, and now our training inputs have been imported. So if you can see here, so it's all a feature collection. Our buildup has 7 training inputs, and agriculture land have the 5, water has 13, and the barren land has 3 training input. So in order to give it as a feature collection in one bundle, so I am using a function called flatten. So let's create a one more variable called training. So yeah, I have created one more variable called training, and I am using the function dot feature collection. Okay, so I am taking all our training inputs, which are buildups and agree, cultural lands as agree, and water. Last one is our barren land. Yeah, so use the function flatten in order to make it into a single collection. So yeah, that's it guys. So our training input is ready now. So now we need to sample the regions and create a training features. So we are taking our pre-image, not pre-image, so we are taking our image. So before going for image, we should also have the prediction bands defined. So I am using one more variable called prediction bands. So from this I am selecting the sentinel bands, let's say b2, b3. So you can have more number of bands so that your classification will be better. So b4, b5, b6, b7. So these are all rated bands. I'll show you it then. b8, b9, b11, and b12. These are the shortwave near infrared bands. So if you just go to the sentinel to image collection, here you can see the band description. So aerosol band is of 60 meters, so I have excluded it. So remaining all we have included from b2 to b8 till the near infrared, and b9 we have water vapors for detecting them, and shortwave infrared and shortwave infrared 2 we have included the 2 bands now, 2 bands of shortwave infrared. So that's it. So let's take our image, which we have filtered it earlier, and used the median function which we created earlier. And for this let's sample the regions. So it's asking for some documents, not documents, arguments. So the collection should be training, and the property should be which we have defined earlier. Here you can see the property we have named it as class. So while taking the samples, it should consider this class for taking the samples from each pixel, and the scale should be 10, and the projection tile scale are not required. So geometries, if you want, you can simply give true, or else you can also remove that also. So close the flower brackets, and let's create another variable called classifier. So with the help of these training features we are classifying, we are using dot classifier function with the random forest algorithm. It comes with the prefix smile random forest. So I'm using a 500 decision trees. So if there is more number of decision trees, your classification would be better. And for this I am using the training function classifier.train, and it asking for some document arguments. So let's open the flower brackets again, So we have to give the features which we have created earlier, which is the training features. Here you can see I have created it earlier, and the class property should be yeah, the class property should be class, which I have showed you earlier, and the input properties should be prediction match. So it should apply the classifier to this map. So remaining value can delete and close the flower brackets, and let's classify it. So let's rename it as supervised classification. Simply supervised is enough. And I am taking this image now, and selecting the prediction bands, and use the function classify with the classifier. So please be careful while practicing the codes. So now my classification is done. Let's add this to layer with the function map.add layer. I am adding the supervised class, and it should also give the visualization parameters. Let's say minimum is 1 and maximum is 4, because we have only the 4 classes, and we should also give the palette. Let's say for the class 1 is our build-up, so let it be gray for the build-up lands, and for the agriculture lands let it be a light green. So you can also use the octocode for the coloring the palette, and next is our water, so let's give it a blue color, and next class is our barren land, so let it be a yellow color. So you can always change this, don't worry. So let's rename our layer as supervised classification in the layers panel. So let's give it a run. Let's see if we get any kind of error or no. So only our true color composite is loading. So if we get any kind of error, we'll get it in the console tab. No, our classification has worked. So clearly you can see we have much of agricultural land, which is in the lighter green color, and we have a river which is clearly depicted in the blue color, and some small lakes are also there here and there. So if you can just uncheck this true color composite and just zoom in and zoom out, so in order to verify the water body, clearly you can see how it has worked. So this is the difference between the supervised and unsupervised classification. So I'm sure you will have a better kind of accuracy in place of training inputs. While giving, you can also give the more kind of training inputs, your classification will be better. So in our next video we will show you how to go for the accuracy assessment for this data only. So we'll use the kappa coefficient, we'll also use the confusion matrix in the Google Earth engine, how we can derive it, how we can interpret it. So everything will be covered in the next video. So the script code for this will be given in the description box, so feel free to ask if you have any kind of queries. So thank you for watching. That's it for today. Thank you.